Hello friends, welcome to EMTECH channel. This is yet another video in this channel. In this video we are going to see about transformer testing. In transformer testing we are going to see today breakdown voltage test. And what is breakdown voltage test? What is the significance of a breakdown voltage test? And based upon which standard it is being carried out? And what are the testing procedures for carrying out a breakdown test? We are going to see today. Let's start the video. Breakdown voltage test is conducted to check the dielectric strength of the transformer oil for oil cooled transformers and instrument transformers such as current transformers, potential transformers, and for oil filled on-load tap changers and for oil filled circuit breakers. Transformer oil serves for two purposes. One is for cooling the core and winding assembly in the transformer, and second, it acts as an insulator between the transformer tank and between the core and winding assembly. And it is one of the important tests to check the quality of the transformer oil other than moisture, pH value, etc. Even though there are 8 to 10 tests that is to be carried out in a transformer oil and it is mandatory, breakdown voltage test is one of the important tests, and we are going to see today about this in this video. And it is a statutory requirement as per Indian standard. And this is a schematic. You can see here the core and winding assembly is placed in the center of the transformer tank and it is surrounded with the transformer oil, and this oil serves as the cooling for a core and winding assembly as well as act as an insulator between the core and winding assembly to the tank. Transformer tank is of metal part conductor, and even the transformer core and winding assembly is also a metal part conductor, and in between this transformer oil act as an insulator, and any insulator that is being placed between a two conducting material is called as a dielectric. And we are going to check this dielectric functions, dielectric quality of the transformer oil, and based upon which standard this breakdown voltage test is carried out. It is carried out based on two standards, two Indian standards. One is IS 1866 and the second is IS 6792. IS means Indian standard. The year that comes after this standard is the revision year. And IS 1866 is titled as Code of Practice for Electrical Maintenance and Supervision of Mineral Insulating Oil in Equipment. And IS 6792 is method for determination of electric strength of insulating oil. In this, instead of a transformer oil, it is given as a mineral insulating oil, because the oil doesn't only use for a transformer, it is also being used for current transformer, potential transformer, as well as for oil filled circuit breakers and for on-load tap changes. So the generic name is given as mineral insulating oil. So first we will see the abstract of IS 1866-2000. This IS 1866-2000 categorizes oil-filled equipments into 8 categories as per their highest system voltage and specifies the recommended limits of the breakdown voltage of mineral oil used in the transformer. It categorizes oil-filled equipments into 8 categories. You can see here from O to G. Power transformer with the highest system voltage above 420 kV falls in O category, and power transformers with highest system voltage above 170 kV and up to 420 kV falls in A category, and power transformer with highest system voltage above 72.5 kV and up to 170 kV falls in B category, and power transformer with the highest system voltage up to 72.5 kV and oil filled switches falls in a C category. And as I said before, the current transformers and potential transformer called as the instrument transformer with highest system voltage above 170 kV falls in D category, and instrument transformer with the highest system voltage up to 170 kV falls in E category, provided these instrument transformers are of oil filled type. And diverter tanks on on-load tap changers comes under F category, and oil filled circuit breakers falls in G categories. So the frequency of breakdown testing is as follows: from category O to category E after filling or after top up, before energizing, and it should be conducted yearly. This test to be conducted after filling or after top up before energizing, and it should be conducted yearly once. And for category F, that is for diverter tanks on on-load tap changes, it should be conducted for after filling or after top up, then every 4 years or 70,000 operations. And for category G, oil filled circuit breakers, and it is in this The frequency is as per the manufacturer's specifications. And what is the highest system voltage? It is the maximum voltage at which the equipment can operate safely. Normally, we will call voltage levels as 400 kV, 33 kV, 110 kV like that. Even though it is a system voltage, the manufacturer will give additional loading factor so that even if the voltage is slightly increased, the equipment will not get damaged, and hence that name is called as highest system voltage. So this standard purely based upon the highest system voltage, and it specifies and categorizes the equipment based only upon the highest system voltage and not upon the normal system voltage. So highest system voltage is the maximum voltage at which the equipment can operate safely without any issue. And next we are going to see about the recommended limits of the unused mineral oil in new power transformer. I already said before, mineral oil is a generic name, and up to 72.5 kV of highest system voltage, minimum breakdown voltage should be 40 kV, and from 72.5 kV to 170 kV, the minimum breakdown voltage should be 50 kV, and above 170 kV, the minimum breakdown voltage should be 60 kV. And the duration up to which this voltage is to be withstand is not mentioned in the standard as far as my knowledge. If it is mentioned in the standard, kindly comment below. As a rule of thumb, it is maintained up to 1 minute. And next we will see IS 6792 and the abstract of it. It defines the method for determination of electric strength of insulating oils and its testing procedures, and the abstract of the standard is the test cell in which the oil is to be filled should be made of a glass or rigid oil resistant plastic and should be transparent, and it should have capacity to hold the volume of 300 ml to 500 ml oil, and the dimensions are mentioned in the standard. Copper, bronze or stainless steel polished electrodes should be used, and the gap between the electrodes should be 2.5 mm. And the supply voltage of 40 Hz to 60 Hz should be applied between the electrodes with the oil filled in the cell, and the voltage to be increased at a rate of 2 kV per second till the limit is reached or till the breakdown occurs. And 6 tests of such kind to be taken, and the average of these 6 tests is the breakdown voltage of the oil. And after each breakdown, the oil is gently stirred to keep away carbon particles from the electrodes and to avoid air bubbles. The first test is carried immediately after the oil is filled and air bubbles are disappeared, and for the remaining 5 tests, the voltage is reapplied 1 minute after the disappearance of the air bubbles. And this is a schematic of how the test cell would be. You can see this is the test cell, and in this the bronze or copper or stainless steel polished electrodes will be there, and the gap between them is a 2.5 mm gap will be available between them, and the oil is filled in this, and the 40 Hz to 50 Hz supply frequency is given, and the voltage will be increased at a rate of 2 kV per second till the breakdown occurs or till the recommended breakdown voltage level is reached. And now let's see how this breakdown voltage test is carried out inside. See here, oil is being filled into the test cell, which is made up of rigid plastics in this case, and this test cell is also designed as per the standard, and the oil is filled up to the top so that the electrodes are fully immersed in the oil. Once the oil is filled, it is kept into the test kit designed as per the standard. You can see here, the supply will be fed to the electrodes by the 2 metal parts extending outside the test cell, and this is the test kit which is designed as per the standard with the custom made operation interface. The red and green patterns seen here act as both switch and indicator. When the red color switch HT on is pressed, HT supply will be energized, which can be seen from the red indication. The green button is used as a switch to switch off the HT supply, and if the breakdown occurs, it will output green indication. The toggle switch, which you see here, is a 3-position toggle switch, which when shifted to left decreases the HT voltage, and when shifted to rightmost increases the voltage, and when left in the middle position, the voltage will remain constant. You can see the voltmeter that ranges from 0 up to 80 kV. Now we are increasing the voltage gradually by pressing the HT on button, shifting the toggle switch to right, and you can see the voltage is increasing, and we increase up to 40 kV. and will wait for 1 minute, and now as 40 kV is successfully withstood, we are increasing further and you can see the breakdown will occur now. You can see the test cell with two electrodes of 2.5 mm gap between them, and you can see now the breakdown occurred and is evidenced by the way of spark, and you can see it in slow motion. And this is how breakdown test is being carried out. As the oil between the conductor lost its insulating property, it became as a conductor, and as it became conductor, the two electrodes will become a short circuit and it trips the kit. The voltage at which this oil loses its insulation property is called breakdown voltage. If you like the video, do like, comment, share and subscribe the video and press the bell button next to it so that you will be notified whenever I post new videos. Thank you. Bye. We'll meet in next video.